During the late 1500s and early 1600s, scholars and scientists increasingly realized the importance of experimentation and mathematics to scientific advances. This realization helped bring about a revolution in science. The ideas of the scientific revolution laid the foundation for a modern worldview based on rationalism and secularism. It gave Europeans a new way to view humankind's place in the universe. In the Middle Ages, many educated Europeans took an intense interest in the world around them. However, these natural philosophers, as medieval scientists were known, did not make observations of the natural world. These scientists relied on few ancient authorities, especially Aristotle, for their scientific knowledge. A number of changes in the 15th and 16th century caused the natural philosophers to abandon their old views and develop new ones. Renaissance humanists had mastered Greek as well as Latin, and thus had access to newly discovered works by Ptolemy, Archimedes, and Plato. These writings made it obvious that some ancient thinkers had disagreed with Aristotle and accepted authorities of the Middle Ages. Other developments also encouraged new ways of thinking. Technical problems that required careful observation and acute measurements, such as calculating the amount of weight that ships could hold, served to stimulate the scientific activity. Then, too, the invention of new instruments, such as the telescope and microscope, made fresh scientific discoveries possible. Above all, the printing press helped spread new ideas quickly and easily. Mathematics played a very important role in the scientific achievements of the 16th and 17th centuries. The study of mathematics was promoted in the Renaissance by the rediscovery of the works of the ancient mathematicians. Nicholas Copernicus, Johannes Kepler, Galileo, and Isaac Newton were all great mathematicians who believed that the secrets of nature were written in the language of mathematics. After studying and sometimes discarding the ideas of ancient mathematics, these intellectuals developed new theories that became the foundation of the scientific revolution. Especially significant in the scientific revolution were the discoveries in astronomy. These discoveries would overturn the conception of the universe held by Westerners in the Middle Ages. We're going to talk about the Ptolemaic system, Copernicus and Kepler, Galileo, and Isaac Newton. Ptolemy was one of the greatest astronomers and geographers of ancient times. He was also known as Claudius Ptolemaeus. Almost nothing is known about his life, but scholars have determined that he made great astronomical observations in Alexandria, Egypt. Ptolemy's observations and theories are preserved in a 13-part work entitled Mathematics, Syntaxis, or Mathematical Composition. This work was so admired that it became known as the Almagest, meaning the greatest. Ptolemy rejected the idea that the earth moves. He pointed out that the earth is spherical and claimed that everything in the universe moves either toward or around the Earth's center. For example, heavy objects fall in straight lines toward the Earth's center, and according to Ptolemy, the sun, moon, and planets, as well as the stars, move around the Earth at various rates of speed. Ptolemy believed that the stars were at fixed points of light in the rotating sphere. Against the background of stars, Ptolemy traced the motions of the planets and worked out a theory for each of them. He stated that the planets are much closer than the Earth and the stars, but are farther away than the moon. Ptolemy developed his system of astronomy largely from the ideas of the Greek astronomer Hipparchus. Ptolemy's system of astronomy was accepted as the authoritative throughout Europe until 1543. That year, Polish astronomer Nicholas Copernicus formulated his theory that the Earth is a moving planet. Copernicus showed that Ptolemy's system was based on questionable assumptions and arguments. Copernicus was a mathematician that felt like the geocentric system was too complicated. He believed that his heliocentric or sun-centered conception of the universe offered a more accurate explanation than the Ptolemaic system. Copernicus argued that the sun, not the earth, was at the center of the universe. The planets revolved around the sun. The moon, however, revolved around the earth. Moreover, according to Copernicus, the apparent movement of the sun and around Earth was really caused by daily rotation of Earth on its axis and the journey of the Earth around the sun each year. Copernicus presented his theory in his masterpiece, on the Revolutions of Heavenly Spheres, published in 1543. In this book, he showed how the Earth's motion could be used to explain irregularities in the movements of other heavenly bodies. Copernicus could not prove his theory, but his explanation was mathematically strong. It also relied on a simpler set of assumptions than Ptolemy's theory. However, Copernicus did use a complex series of circles to account for certain irregular motions. He made this assumption because, like many other astronomers of his time, Copernicus believed that planetary motion was based on perfect circles. Copernicus' ideas about the roles of the sun and planets were essentially correct. He's considered the founder of modern astronomy. However, the German astronomer Johannes Kepler showed that the planets follow elliptical or oval, egg-shaped orbits, eliminating the need for a complicated series of circles. Also, in the early 1600s, the Italian scientist Galileo made discoveries with the telescope that supported Copernicus' theory. The great Italian scientist Galileo stressed the need for carefully controlled experiments. In his research, Galileo used observation and mathematical analysis as he looked for cause and effect relationships among natural events. He recognized that experimentation could lead to the discovery of new principles. For example, Aristotle had taught that the heavier an object is, the faster it falls to the ground. Galileo questioned that idea. He set up experiments to find true laws of falling bodies and provided that Aristotle was wrong. Through experimentation, Galileo discovered many basic principles of mechanics. Galileo also saw the need to extend the range and power of human senses with scientific instruments. He improved such instruments as the clock and the telescope. With the telescope, Galileo found convincing evidence supporting Copernicus' heliocentric theory. Another remarkable scientist of the 1600s was Sir Isaac Newton of England. Newton used the findings of others to develop a unified view of the forces of the universe. In his book, Principia, he formulated a law of universal gravitation and showed that both objects on Earth and the heavenly bodies obey this law. Newton's studies of lenses and prisms laid the foundation for the modern study of optics. Newton and Gottfried Wilhelm, a German philosopher, independently developed the system of mathematics, calculus. It's hard to describe how important Sir Isaac Newton is to science. He's been described as one of the greatest names in the history of human thought because of his great contributions to mathematics, physics, and astronomy.
Made with Doodlecast Pro.